This video is going to take a little bit of a sidetrack to talk a little bit more about parallel lines. We're going to talk about parallel lines in a lot more detail in a few weeks when we get into doing proofs. We're going to need a lot more vocabulary and a lot more facts at that point, but we just need a little bit of vocabulary and a fact or two in order to finish up our constructions. So let's see what we've got to work with. All right, so here I am in GeoGebra, and I'm going to start off by creating two parallel lines. So what does it mean for lines to be parallel? Well, there are a couple different ways of thinking about it. You can think that these two lines don't cross each other, no matter how far we stretch them out in either direction. You might think that these are two lines that are heading in the same direction in some sense. You can think that the distance between these two lines isn't changing. A couple different ways that you can think about parallel lines. But mathematically, these two lines just sitting here alone, not intersecting each other, is a bit boring. So what I'm going to do is I'm going to add a third line that crosses these two lines. Boom, just like that. And the vocabulary word that we're going to use for this is we are going to call that third line a transversal. Okay, so it's crossing the two parallel lines. So it's transversing those lines. That's why we call it a transversal. So when we've got two parallel lines cut by a transversal, how many angles are formed? Well, let's take a look. We've got 1, 2, 3, 4 around the top point, 4. And we've got 5, 6, 7, 8 when we consider the bottom intersection point. All right. So my next question is, if we got out a protractor and measured those 8 angles, how many different responses do we think you could come up with? Do you think it's possible that all 8 angles could be different? And if not, what's the maximum number you think we could come up with? Well, one thing that's a little bit cool is that these two lines are vertical angles, so they've got to be congruent. We talked about vertical angles before. We've got two vertical angles down here at the bottom as well, and it turns out that these 4 angles are all congruent to each other. We'll talk about these relationships later. And in the same way, the 4 obtuse angles are also all congruent to one another. All right, so looking at the 8 angles, there are really only 2 different sizes. So that's a pretty cool fact. But what we need to walk away with today is the notion that if we have 2 parallel lines cut by a transversal, that these 2 marked angles have to be congruent to each other. All right? And the same thing is true in reverse. If we've got 3 lines like this, and I didn't know if these 2 lines were parallel or not, but I did know that the 2 angles here formed by the transversal were congruent to each other, that's enough information for me to know that these 2 lines are effectively pointed in the same direction, and therefore those lines must be parallel. All right, so the fact about the 2 lines being parallel and these 2 angles being congruent go hand in hand. Either one of them imply the other. All right, and that's enough information for us to wrap up our construction unit and do the last of the toolbox constructions. And then from there, we're going to take off and do 3 bonus constructions. But first things first, which is wrapping up the last of our constructions, which is going to be constructing a parallel line.